you see me? Great. So one more time, I want to start with a picture. Who remembers this machine? Some of you? Yeah, it's a good old C64, a Commodore 64, the hero of my childhood. It was released in 1982. That really shows that I'm growing old nowadays. And it had 1 megahertz. 1 megahertz, which is nothing compared to nowadays capacities. It had 64 kilobytes of RAM, and the disks could store 170 kilobytes. So that was not much. What no one knows is that even because of this limited resource set, there have been a dual-core version, a version with 2 CPU cores. It looked like this. And of course, the biggest challenge back then has been resources. You had to think twice before you used an integer. Perhaps a tiny integer was enough, or perhaps just a fraction, the left side, the right side of an integer was what you needed. Resources is not a big issue anymore, especially in transactional systems, systems for use cases. In those transactional systems, we have other advantages or other challenges like long-time maintainability. We have to make sure that our software can be maintained in long term, let's say for 10 years, for 20 years, or something like this. And then, in addition, there is this issue with milk products. Perhaps you have heard about this issue with milk products, namely, there are milk products out there lasting longer than some JavaScript framework. So the area of JavaScript is really moving fast. And some weeks ago, I heard someone say to the other one, what you are doing here is that much 2015. So just do the math, 2015, it has been 4 years and some dude is finger pointing to you because you are using something that was popular back then. I think that really shows how fast we are moving here, and that shows that we need to find a solution to provide something that can be maintained in long term. And such a solution could be web components. Web components are framework-independent components that are written with one framework or with vanilla.js, and they can be reused with each and other framework or even with vanilla.js. This workshop is exactly about this topic, and in this workshop I will show you the basics about using web components. I will show you how you can use web components together with Angular elements. I will show you how to deal with polyfills, as well as how to dynamically add a web component to a page. We will load also external web components. That means we will look into standalone components and lazy loading. So this is quite similar to the session I've done this morning, but now I will do everything using live coding. That means you will see everything live and in action. Before we start, let me introduce myself. I'm Manfred, I'm a trainer and consultant. I'm focusing on Angular, and I'm part of the Google Developer Expert team, as well as of the Angular team at Google. I'm a trusted collaborator there. And my current product is also about Angular. It's a workshop for Angular in the enterprise. It contains a lot of advanced stuff. Okay, let's get started with web components. Perhaps you remember, this morning I told you there is not such a thing as a web component. And the reason is web components are just an umbrella term for some technologies, for some standards that allows us to write framework-independent components. For instance, when you look into web components, you will find something like templates. I think every one of you knows templates because templates are omnipresent. You find them in Angular, you find them in React, you find them in each and every other framework. In Angular, nearly each and every component has a template of its own, but also a if or a for has a template that is hidden or displayed or repeated. So templates are not a big deal. The next standard here is Shadow DOM. Shadow DOM allows you to decouple your component from the rest of the DOM. Perhaps you know this situation where you have two or several CSS files and both of them work perfectly, but in the moment where you include both of them at the same time, hell breaks loose. They are affecting the same elements and the whole application looks like a mess. This is prevented by Shadow DOM. Shadow DOM allows you to render a component in isolation. And then there is custom elements, which allows you to teach the browser new tricks. You can define new elements like table, like image, like form, and they will behave exactly like built-in elements, but with your own logic, with your own design. When it comes to templates, as mentioned, they are omnipresent in Angular, as in most of the current single-page application frameworks. Shadow DOM is also baked in. Since Angular 2, we are always using Shadow DOM. By default, we are using an emulated version of Shadow DOM, which means that Angular is rewriting your CSS code so that the CSS just affects your component and not other components. Perhaps you figured this out when you are looking into the source code of your page within the browser. You will find some prefixes that are put to your CSS classes. This is done by Angular just to emulate Shadow DOM. You can even use the traditional Shadow DOM that is provided by all the newer browsers. And when it comes to custom elements, we have Angular Elements. It's quite new, it has been around for a year, and it allows you to turn a traditional Angular component into a custom element and so also into a web component. And now I would say, let's have a look at this in action. For this, I'm switching to a sample application I've prepared. It takes some seconds until the beamer is catching up. And the sample application contains a dashboard. You have seen this dashboard this morning. And of course, this dashboard contains a dashboard dial. When we look into this dashboard dial, we see it is an ordinary Angular component. There's nothing special in here. It is an Angular component that takes three inputs, A, B, and C. It has a data object, and Engion init is populating this data object with the values of A, B, and C. I am also assigning some levels like also A, B, and C. If we look into the HTML template of this dashboard dial, we also see there is nothing special in here. It is just some HTML boilerplate, and in the middle we have a call to an Angular component, ngx charts by chart, which gets our data structure, and we are telling the pie chart that it shall display all the labelings. So it is nothing more than this. Let's have a look at the module of this component. Here in this module, I'm just declaring this component and I'm exporting it. And that means I can immediately use it within Angular as an Angular component. But now I want to make a custom element out of it. And so the first thing I need to do is to put it into the entry component section. Entry components are components that are created on demand, on the fly, and this holds true for Angular elements. When the browser detects that they are there, the browser is requesting that they are rendered, and so Angular needs to create those components on demand. Also, we have to define some wrapper code, some code that makes a web component out of our Angular component. You can put this wrapper code everywhere. You can put it into a service, into your startup procedure. You can put it into another component. You could even put it into a pipe. I am putting it here into the constructor of my module. So that means here within my constructor, I'm calling create custom element. I'm passing the dashboard tile component in. I'm also passing in the injector so that this component can make use of dependency injection. And the result is just a custom element. A custom element I could also hand write with pure HTML and JavaScript code. And then I have to register this custom element with the browser, not with debug, but with custom elements.define. I have to assign a name like dashboard tile, and then I can assign custom element. And that's all. Now I have already a custom element in my browser that can work with other frameworks too. So let's try this out. Let's move to my home component, and here let's add a dashboard tile. Dashboard tile without an app, and you are seeing some squigglings here, and those squigglings are telling us that something will occur, that something bad is coming up. Okay, let's have a look into our application, and hey, you see, boom, we've messed everything up. Somehow the application is not even starting. Somehow the application is damaged because of this Angular element. So every time you see something like this, you should look, of course, into your console, and here you see a very big exception. And this exception is also proposing two possible solutions to your issue. It is telling you, hey, I don't know dashboard tile. And yes, the Angular compiler cannot know the dashboard tile because dashboard tile is not an Angular component anymore. It's now a web component, and the Angular compiler is not aware of it. And now there are two proposed solutions. The first solution is we could use the dashboard tile as an Angular component and declare it. Or if it is a web component, then add the custom element scheme to your module. This custom element scheme is easing the compiler. It is telling the compiler, hey compiler, everything is cool. You will see something you don't know, but you don't need to be afraid of things you don't know, just ignore them. So it is somehow opium for the compiler. So let's move to my app module. And this is where the scheme goes. There is this own scheme section. It is rarely used, but now we need it for custom elements. And when we look back into our application, we will see, yes, it works a bit. But now let's move to the home component, and boom, we get another exception. What's going wrong here? Well, when we look into that, we see an error message that tells us that it was not possible to construct HTML element. Please use the new operator, blah, blah, blah. And this error message is everything but not self-describing. If I have seen it the first time, I just wanted to jump out the window because I did not know what to do. Meanwhile, of course, I know what this means. Meanwhile, I know that this means that we need polyfills for our application. Polyfills that make the application work. So let me just talk a bit about polyfills. Let's start with the good message. The good message is that we can mostly everything polyfill, even for IE. Who has to support IE? Yeah, some of you, about the half. For some reason, it's still a topic. It's also a topic for my customers. In many companies, IE is still the default browser, and so we have to make sure it works there. And yeah, we can use polyfills. Of course, those polyfills are not perfect, but if you know their limitations, you can arrange with them. The polyfills I'm proposing is the Polyfills web components.js. It has been created within the Polymer project, a project where Google started very early experimenting with web components. And yeah, this polyfill is a bit bigger. It has a bit more bytes than some other polyfills, but it allows to support IE. Something that really breaks my heart is that we need two polyfills. The first polyfill is some kind of polyfill loader. It loads support for all the lacking features like custom elements, like shadow DOM and templates. And the second polyfill is called the ECMAScript 5 adapter. This is the heartbreaking one, because this one is needed, and now take a deep breath. It is needed for browsers that do support custom elements. Somehow awkward, isn't it? We have a browser that does support custom elements, and even though we need an adapter for it, even though we need a polyfill. So what's the reason here? The reason is that web components are defined for ECMAScript 2015. But to be compatible with IE, we are most of the time down-leveling to ECMAScript 5. And the modern browser is not aware that a web component can be written with ECMAScript 5. And if this modern browser sees something like this, they are saying, hey, what we are doing here, this is not allowed. The specification says clearly ECMAScript 2015. So one more time, to ease the browser, we need some opium. We need this adapter here, and so everything is fine. Saying this, there is a better alternative since Angular 8. Since Angular 8, which means since 2 or 3 weeks, we have differential loading. Who played around with differential loading? Okay, it's quite a new feature. Differential loading means that you are compiling your application twice. Once in form of an ECMAScript 5 bundle, and once in the form of an ECMAScript 2015 bundle. And then the browser decides which bundles to load. Of course, modern browsers will load ECMAScript 2015, and old browsers will load ECMAScript 5. And that means that modern browsers will just see modern code, and so we don't need this adapter for them. So just to be on the safe side, I'm using both polyfills, the loader and the adapter, to make everything work in each and every environment. Okay, let's have a look at a demonstration for this. Now we have to install some polyfills, and of course we could now go to the internet, search for the right polyfills, download them and import them to our application. But I have something better for you. I've written this open source tool. It's called ngxbuild plus. It contains several features you need for web components in Angular nowadays, and one of those features is it installs your polyfills. You can just ng-add it. You see, it works together with the Angular CLI. Just ng-add it, and then you should get it installed in your application. Yeah. After this, you can say, hey, ngxbuild plus, please generate web component polyfill support. Okay, perhaps the prefix WC is not the best prefix because there are different meanings to it, but I think I will stick with it. Okay, so everything is downloaded. The right files are updated. Some polyfills are copied to the assets folder so that they can be injected on demand. And on the end of the day, we should be good. Yeah, it worked. So in some cases, this is just enough. In other cases, I have to restart the CLI. Let's try it out. Okay. In this case, let's restart the CLI. ng-serve. Def goes down. And nothing works. So let me just look into my source code. Seems like I've messed something up. Let me have a look into my index.html. Here we did not get polyfills. Let me have a look into my polyfills.ts. Yeah, here we got some polyfills. For some reason they are commented out. Normally you should just get those 2 lines of code that makes everything work. And then let's rebuild it and let's cross fingers. Yeah. Nothing works. How bad is this? So what shall I do now? Let me just think about it. Perhaps just give me a second. Please hold the line. I have a backup. So let's install this backup. It can be only a matter of hours, so yeah, so seems like I've managed to deal with my Polyfills issue. I'm very sorry for this interruption. And here we see that my web component is displayed. Okay, great. So perhaps you are saying now, hey Manfred, what are you doing here? You are using that much things and you are having so much troubles with polyfills and with the custom element scheme and so on, just to display a diagram on the screen. Is that really worth the effort? And well, the answer is it depends. It really depends. In some cases, it's worth the effort, especially if you have to reuse this with other frameworks or if you have to reuse this in a very dynamic way. For instance, if you wanted to add those dashboard tiles in a dynamic way to your screen, then it's totally worth the effort. But if you just need an ordinary Angular component that is statically displayed in here, please do not go with Angular elements. In this case, just stick with an Angular component. So to make this more meaningful, I've prepared this dashboard example you've seen in the morning. And this dashboard example allows me to dynamically add my things to my dashboard. So when clicking here to add default, then this dashboard tile is dynamically inserted here. And for this I would say, let's have a look to this application. So let's switch to my dashboard page. And when you look here to my dashboard page, you are seeing I have an add method. It's called add tile. And this is the method that is called when I'm pressing the button. And this add dial is calling underscore add, which is a private helper function, and underscore add is doing the magic. It is defining 3 random values, and then it is grabbing into the page and taking the content of my dashboard. This is where I will insert all the dials. And then I'm creating a new element, a new dashboard dial. So by default, dashboard dial is passed here. And then I'm hooking up some attributes. I could also hook up some properties or an event handler. And then I'm just adding this dial to my page here. This is what happens here, and this is what makes everything dynamic. Of course, this would also work with traditional Angular components, but it would be far more difficult to deal with dynamic Angular components in a similar way. Here you can just leverage a 20-year-old API and it just works. But now let's go one step further. Let's try to lazy load these components. For this I've prepared another component. It's my lazy dashboard dial, and it looks the same like the other dashboard dial. It's also declared here with a module. It's put into the entry components, and here it is also made to a custom element using create custom element. So not a big deal, the same as before. But now I want to load this whole module in a dynamic way. Normally we are doing this with the router, but this here is not about lazy loading routes. This here is just about lazy loading some components, perhaps a module because it's necessary for technical reasons that contains one or several dynamic components. And to accomplish this, I have to do 2 things. First of all, I have to go to my Angular JSON, and there I can put this module. There is a property lazy modules in here where you can define all the modules you want to lazy load. And after that, you can write some code that allows you to do this all in a dynamic way. For this, let me switch over to a service. I've called it lazy dashboard dial service. And as you see here, I'm getting hold of an ng module factory loader, which is an internal tool, an internal API of Angular. I'm also getting hold of the injector. And then I have here a load method that does the heavy lifting for me. Let's make the linter happy. If we look into this method, first of all, I'm checking whether this very module has been loaded. If it has been loaded, I'm saying, hey, let's go away. We don't need to do it anymore. Loading it once is enough. Then I have this constant here, and this constant, as you see, is pointing to my module. Then it has this hash, and then it is pointing to the name of the module class. So what I'm saying here is, please load this file, and within this file you will find this class with this name. It's the name of a module class. Yeah, and then I'm using the loader. It has this load function, loader load. I'm passing in the path, and I'm getting back a module factory. And this module factory has a create method. I can call it, and so I can instantiate my module. And because this module comes with web components, we can use those web components immediately. We don't need to look them up in the middle of the module. We can just use them immediately. So let's see this in action. Let's move back to the dashboard page component. And here you see add lazy. Okay, here we get a message. If you try this exercise using Stackblitz, I've prepared all these exercises for you within a Stackblitz example. You cannot do this part because this part demands you to do everything locally. Lazy loading that way will not work with Stackblitz. And then I'm saying, hey, lazy service, please do what you are doing. Please load this lazy chunk. And when we are done, then I'm just adding my lazy dashboard tile using this underscore add method to my dashboard. So I'm doing more or less the same as before. And as we see here, it kind of works. Perhaps you are a bit afraid of race conditions. Let's say the order here is not right. So here we are adding it before it's loaded, which is somehow a mess, isn't it? Well, let's try it out. It works. How cool is that? This works by definition. You know, by definition, the browser has to ignore everything it does not know. And in this case, in the first seconds, it ignores this lazy dashboard tile element. And then when the browser loaded the bundle with the Angular element, with the custom element, the browser has to revive this unknown element and it has to request rendering. This is by definition, and so you don't have to fear race conditions. It's nice, isn't it? Yeah. Cool. Well, let me show you one disadvantage of lazy elements, and for this I will use this flip chart here. One disadvantage of lazy elements is that everything has to be compiled together. Let's assume that this is your code base. The whole code base has to be compiled together, and only after the compilation, during the build steps, the lazy chunks are removed from your big main chunk. So you're ending up with a lazy chunk, and you have a main chunk. Perhaps you have other lazy chunks. And sometimes it's a drawback to have the need to compile everything together. Sometimes you want to compile your web component separately, which would be something like this. You would compile your own web component. You would put it on this or that server, and then on demand you are loading it from the server in the newest version or in this or that version. This is what I'm doing next. Well, saying this, using those external components I'm going to implement now, this is currently not supported because of bundle size. You will end up with really huge bundle sizes, but I have some resolutions for this, and hopefully in the future when Ivy arrives, we have an official solution. First of all, to get something like this, to get an external component, we need an own project that just comes with your Angular element. I have prepared this here. No, perhaps it was 33, yeah? And as you see, it just contains this tile, this dashboard tile. Of course, it could also contain several other tiles, but in this case, it's just this tile. Let's have a look into the source code of this. If we look into the source code of this, we see, for instance, an app module that looks like an ordinary app module at first sight, but on second sight, there are some tiny differences, something you might not know from your project. Who is seeing a difference here? Something that's special. What do you say?
There's no bootstrap component.
Yeah, right. There's no bootstrap component. And this is for a reason. I don't want to bootstrap an Angular component. I just want to start Angular to provide the Angular elements. But I don't need a traditional Angular component here. Do you see another thing that's not usual? What would you say? ng2 bootstrap, right, yeah. So Angular demands us to write an ng2 bootstrap method if we don't have a bootstrap component. Angular is right straight about this. Angular is saying, hey, Either you are bootstrapping something by yourself, or I have to bootstrap something for you. If I have to bootstrap something for you, then you have to put the component into this bootstrap array. So we either need something in here, or we need this method. And when you look into this method, it is doing what we have done twice before. It is just wrapping an existing Angular component as a web component. Okay, so this is all more or less. And now let's try to compile this. ng build ---- prot. And of course, this takes some time now. And check, we get an error. But that should not bother us. What did I do here? External, add app component to the ng module. I think it's not a big deal. I think it is just complaining because I've not added this component here. But on the end of the day, we are seeing we got 5 bundles. 5 bundles, which is not less, for a tiny dashboard tile. No one will use this dashboard tile if they have to include 5 bundles. But this is what's done by the CLI by default, and that's really okay for a full-flagged application. Of course, for a web component, it's not okay, and that's also why I've created this ng-build plus. This ng-build plus comes with a new flag. It's called single bundle. And if I'm using this single bundle flag, then it does not work because I have to install ng-build plus. Just a moment. And then it will work. Then we will get everything with one self-contained bundle. And let's cross fingers. Can it be done? And yeah, we are getting our self-contained bundle. So ignore the Polyfills bundle. You could use it for testing, but normally you would only ship your self-contained main bundle, which now contains everything you need for your web component. But if you look at the bundle size, you see it is rather big, isn't it? So this comes with quite an overhead, and that means we need a better solution for this. But let's talk about this in some seconds. First of all, let's say bundle size is not an issue. I mean, hey, we have a good network connection, so let's load everything we need. And let's switch back to our application. Within our application, we can now lazy load this external bundle. For this, I've written an external dashboard tile service. And when we look into it, we see it is really the simple script loader available nowadays, the simple script loader one can think of. First of all, one more time, I'm checking whether we have already loaded the script, and if this is the case, I'm jumping away. And otherwise, I'm loading the script by creating a script tag, by assigning a path that points to my bundle. In this situation, I've copied it over to my assets folder, but I could also say, hey, let's go with HTTP this and that on this server. Let's grab the newest version that has been deployed over there. And then I'm abandoning the script to my page. Okay, so let's try it out. Let's move back to our application. Let's click Add External, and hey, it is loaded on demand. But, and this is the drawback, it is rather big. So if you look at my very fine graphic on the flip chart, it shows us we have two options. We can go with very optimized bundles, but in this case everything has to be known at compile time. Or we can go with flexible, externally compiled bundles, and then the bundle size will be bigger. And now the question is, what can we do to decrease the bundle size? Well, first of all, we have to find out why this external bundle is that big. Why this external bundle has here, in this case, about 200 Ks. And the answer is, it contains some parts of Angular. It contains all the parts of Angular it is using to display this dashboard tile, and so it is summing up to about 200 Ks. That means we have somehow to get rid of Angular itself. And for this we have two solutions. First of all, we could use ngIv, which is hidden behind the flag since version 8. We can use it, but it's hidden behind the flag, and it's not that ready for prime time, but it could be a good use case for IB, especially if you just have some tiny web components. Or, and this is the second approach, we could try to share some dependencies. Let me show you a slide for this, a slide for sharing dependencies. Oh, that's the wrong set. Let me use the flip chart. So when it comes to sharing dependencies, we are just loading Angular once into our browser. That means we have something like window.ng. This is where Angular itself is living. And then we are loading our bundles with web components, and those bundles will just reuse the already loaded Angular version. To make this usable, we have to use UMD bundles, but the good message here is Angular itself is also shipped using UMD bundles that are putting Angular to the window object. And we have to tweak the CLI a bit. We have to tweak the CLI so that this operation mode is used. The good message is the CLI is using Webpack, and Webpack is capable of this. Webpack has this notation of externals. Externals are just libraries that are not compiled into the bundle, but libraries that are to be expected within the window object. And guess what? The CLI is not capable of this, even though Webpack is, but my tool ngxbuild plus can help with this. So I would say, let's try it out. I've already installed ngxbuild plus, and now I can say nggenerate ngxbuild plus. Please generate externals support. Externals is the name in the world of Webpack. And as you see here, this is generating a lot of stuff, and it is downloading some further stuff, and then we have this new operation. So let us find out what happened here. One thing we've got is a Webpack externals.js. A Webpack externals.js is just a partial Webpack configuration. The Angular CLI has a Webpack configuration of its own, and this configuration is merged into the default CLI configuration. And if you look here, it is just saying, please do not bundle Angular core. Instead of this, expect that you will find the same things in your window object using window.ng.core. And it tells you, please don't bundle Angular common. Instead of this, look into the window object to window.ng.common. Do the same with RxJS, do the same with all the rest here. This is more or less what this solution is doing here. And as you can imagine, you can use this operation mode to tweak the CLI in any way, to squeeze in a lot of different Webpack configurations you want to have or you have to use. Okay, let's now build this example. To build it, we've got created an NPM script that is called build externals. And now you see one more time, patience is a gift. And you see, hey, the main bundle is really slim, isn't it? We've managed to break it down to about 9K. Thank you, thank you. And I think this makes it useful, if you ask me. Of course, we have a drawback. We have to do this special operation mode. We have to load Angular into the window object. We cannot even use tree shaking for Angular because we don't know which parts of Angular are used by all the libraries that are loaded on demand. But it is a first solution. On the other side, also, your index file is a bit ugly. If you look into your index file, you see you have a lot of script references because all those packages have to be loaded step by step. You have to load core UMD, Angular common UMD, common HTTP UMD, and so on. Of course, you could also try to bundle those things together. There are options for this. In this showcase, I'm just loading them directly into my index HTML. This solution works, and I would just recommend to use this solution if you really need it. In some cases, you will not need it, because in some cases, Ivy is good enough for you. You can just depend on Ivy. Saying this, I've just told you Ivy is not ready now. Yes, that's right. And there is not even a bridge between Angular elements and Ivy. But you can use some APIs of Ivy to make it work even though. I've written down a blog article about this. Perhaps you are stepping by in my blog. It is the latest article, Web Components with Angular Ivy in 6 steps. And let me scroll down to show you the general idea. This is the general idea. So what I'm doing here is I'm creating a vanilla web component, a vanilla custom element. On the end of the day, from the side of the browser, a custom element is just a class that extends HTML element. You could write something like this directly into Chrome. Chrome can work with this without compilation because it's also ECMAScript 6. And then look what I'm doing. I'm calling an Ivy function, which is called render component. I'm passing my Angular component in, and I'm saying, hey Ivy, please render this Angular component into this. What is this? This is our component. And so that means our web component will display the contents of this Ivy rendered component. So this is everything you need nowadays to get started with Ivy and web components. Of course, the drawback is you have to provide this boilerplate code. But it's not such a big deal, and hopefully in the near future, Angular elements will do this for you as it does the same for you nowadays without Ivy. Have you noticed something when you look at the name of render component? Yeah, there is a nice ladder. It looks like this traffic sign that tells you you are not allowed to enter the street. And does anyone know what this ladder is meaning?
I provided new functions with that. It's called data functions. Yes?
Yeah.
It's for internal use.
It's for internal use currently. So currently it's a private API. They are just prefixing this with this special character. But hopefully in the near future, perhaps with Angular 9, those private APIs will be made public, and so we can use it safely then. That means if you are an early adopter, you can go with it nowadays, but perhaps things are breaking and then you have to adjust your source code. A lot of my customers are early adopters and they at least need a prototype now to show the company what's possible now and in the near future. So for them, this is somehow okay-ish. So I've also did some measurements with this and I've managed to compress such a component to about 16Ks. 16Ks, of course, is bigger than that what we've got before. We just had 9Ks before, but hopefully Ivy will be a bit more optimized when it's ready for prime time. And with this Ivy trick, we don't have to deal with all the consequences of externals, with loading everything to the window object and so on. Perhaps you are wondering when to go with which solution, and the rule of thumb is if you have an UI-based widget, go with Ivy. Ivy is really good with UI-based widgets. If you have a library, let's say a router you want to share, authentication code, HTTP access code, then go with externals. Ivy cannot do much about the bundle size of libraries, but in the case of libraries, you can just try to share them using externals. Okay, cool. We have some time left, and so I will show you a bonus chapter. Let me search this bonus chapter. It's this here. Zoneless change detection. Who has ever tried to use Angular without zone.js? Okay, some of you, did it work out well? Okay, cool. So the thing is, it's possible. We can use Angular without zone.js, but we have to live with the consequences. So first of all, why do we need zone.js at all? Well, it's used by Angular's change detection mechanism. It batches each and every browser event, and it notifies Angular after each and every browser event, so that Angular knows that we should now update the data bindings. And now the question is, why is it a good idea to get rid of zone.js, especially when you are providing web components? Well, zone.js has over 100 Ks, 12 Ks zipped, but without gzip over 100 Ks. And somehow it is awkward to force the user into using zone.js together with your 5 kilobyte datetime picker. Just think about it. You have a 5 kilobyte datetime picker and you are adding 12 kilobytes just for zone.js. Somehow this is awkward. And so it is a good idea to try to get rid of zone.js. It is possible nowadays. You can use this here. When bootstrapping, you can define the noob zone. Noob means here no operation. And so you will not get zone.js. Zone.js will be tree shaking away. But the consequence here is you have to do change detection by yourself. You can try to trigger change detection using observables, or you have to do it by hand, which might be okay for a web component. Saying this, the Angular team is currently investigating ways to find an official strategy for making zone.js optional. Hopefully, with the next Angular releases, we will find something like this. Nowadays, we have to be creative if we want to get rid of zone.js. We have to find our own way of doing change detection. And this is what I'm doing in my external in my external dashboard dial component. For instance, when we look here to the main.ds file, you are seeing my external dashboard dial does not use zone.js. But instead of this, we have to do change detection by hand. And for this, we have two options. Perhaps there are several options, but first of all, two options came in mind. The first option is using the change detector by hand. You can get hold of the change detection strategy. No, you can get hold of the change detector ref using dependency injection. And every time something changed, you can just say, hey, now please update your data bindings. Now please detect changes. This is the first way. Do it completely by hand. The second way is to expose your data using observables. This is what I'm doing here. For the sake of simplicity, I'm just exposing a replay subject. I know normally a subject should be hidden within a service, but here I'm using it directly. And every time I've loaded some statistic data, I'm just sending this data to the next method of the subject, and then on the other side, the subject is data bound to my template. What do you think? How shall I data bind the subject to a template? How is this possible? Yeah, with the async pipe. This was also what I thought, but this does not work because the async pipe relies upon ng zones, upon zone.js, which means even though we are working here with observables, async would not work. So what I'm using here instead is a home-brewn async pipe. It's called the push pipe. I have not written this push pipe. This push pipe is taken out of an example of an Angular team member that just experimented around. They just wanted to find a way to provide something like an async pipe that even works without zone.js. And this experimental pipe is here called push pipe. And with this push pipe, we are on the safe side. We can just use it as the Angular pipe. And as you have seen before, data binding works with my external dashboard component. There are even further IDs that allows us to get rid of zone.js. One additional ID is each and every component should get or could get a set property function. Let me write it into comments. Set property. And every time I'm calling set property, I can define that, for instance, data gets a new value, for instance, null, and at the end, set property could do change detection. This is similar than we have change detection in React, I guess. And there are also further different approaches here to get rid of zone.js. So at the end of the day, please keep in mind, getting rid of zone.js, making zone.js optional is a good idea. Currently, we have to find a tricky solution, a tricky home-brewn solution. In the future, the Angular team will come with something like this. Okay, cool. We are quite good in time. Let me sum up. We've seen several things here in the last hour. We've seen that this beamer is quite slow, and we've seen that we have to use the right polyfills to make it work with all the browsers. We've even seen that we need polyfills for modern browsers if we are down-leveling to ECMAScript 5. We have also seen that we have to use the custom element scheme because the Angular compiler is not aware of the web components, and to ease the compiler it needs some opium. This is this custom element scheme. We've seen that Angular Elements makes it very easy to wrap an existing component as a custom element. We've seen there is Shadow DOM baked into it. We've also seen dynamically adding everything is just a piece of cake. Just use the document object like 20 years before. And we've talked about dynamically loading those elements. We can dynamically load them using lazy loading, or we can dynamically load an external web component. When it comes to external web components, we have to take care about bundle size. For this, you can go with Webpack externals or with Ivy, which is quite new and hidden behind the flag nowadays. Okay, so thanks for coming. Here you have my contact data. If you want, follow me on Twitter so that we can keep in contact, and have a nice day. Thank you.